Moment of inertia. Now, रोटेशनल मोशन में मोमेंट ऑफ इनर्शिया बहुत ही इंपॉर्टेंट पार्ट है। जब हम बात करते हैं इनर्शिया की, इनर्शिया हम जानते हैं कि इनएबिलिटी ऑफ ए बॉडी टू चेंज इट्स स्टेट। यहाँ पे बस उस स्टेट में हमें ऐड कर देना है चेंज द इनएबिलिटी ऑफ ए बॉडी टू चेंज इट्स स्टेट ऑफ रोटेशनल मोशन इज कॉल्ड मोमेंट ऑफ इनर्शिया। इसके लिए एक्सप्रेशन है, फॉर्मूला है। फॉर्मूला फाइंड करने के लिए we'll be using the kinetic energy formula. So let us find kinetic energy of rotating body. तो जो बॉडी रोटेशनल मोशन में है उसकी काइनेटिक एनर्जी क्या होगी? जैसे अर्थ है, अर्थ अपने एक्सिस पे मूव करती है तो रोटेटरी मोशन है। इसके लिए हमने सोचना यह है कि जैसे हम लिखते हैं काइनेटिक एनर्जी इन ट्रांसलेटरी मोशन, तो काइनेटिक एनर्जी इन ट्रांसलेटरी मोशन हम लिखते हैं हाफ एम स्क्वायर हम जानते हैं कि वेलोसिटी तो लीनियर मोशन में होती है, तो v कैन बी ओमेगा r. नाउ इफ यू कन्वर्ट इट हाफ m r square into omega square means we can consider a body, let's say this one. Zigzag means this is a rigid body having masses m1 and this r1 is the vertical distance. Similarly, it can have many masses. Let's say this is the mn and rn is the vertical distance, and all are having constant angular velocity omega about this axis. So for m1 it can be half m1 v1 square, half m1 r1 square. Omega would be same for all. So for m2 we may write half m2 r2 square omega square. Similarly, we can write for mn, it will be half mn rn square omega square. So if we want total kinetic energy of translatory motion net, the half is common. Then we have some trend, m1 r1 square plus m2 r2 square plus so on mn rn square, and omega square is also common, which means this we write half and sigma I 1 to n mi ri square, and then omega square remains common, and therefore we write kinetic energy in translatory motion as half, and this whole is replaced by a letter capital I omega square, and this is kinetic energy in translatory motion, half I omega square. And in this, what is significant is this I comes for, if you write in general, m r square, and this I stands for the moment of inertia. Moment of inertia. m for mass और r किसके लिए? तो वर्टिकल डिस्टेंस फ्रॉम एक्सिस, राइट। इसकी यूनिट क्या हो जाएगी? m for kg, r for मीटर, तो kg मीटर स्क्वायर। तो ये होगी फॉर्मूला, और इससे हमने एम आर स्क्वायर निकाल लिया। और अगर हम काइनेटिक एनर्जी जो हम इन जनरल ट्रांसलेटरी मोशन से चले थे, तो वी आर गेटिंग रोटेटरी मोशन, राइट? सो आर, नाउ काइनेटिक एनर्जी ट्रांसलेटरी, वी राइट हाफ एम वी स्क्वायर। और दोनों को कंपेयर करें तो हाफ कॉमन है दोनों में, ओमेगा स्क्वायर, ओमेगा रिप्रेजेंट एंगुलर वेलोसिटी, वी रिप्रेजेंट linear velocity, which means I and mass are same. So what role is played by mass in linear motion? Same role is played by translatory motion or rotatory motion. Same role is played by moment of inertia in translatory motion, right? Rotatory motion. So whatever work is done by moment of inertia and rotatory, same is done by the mass in translatory motion. Okay. Now let us look into one more important aspect, which is called the radius of gyration. When we talk about radius of gyration, it means vertical distance of what? Vertical distance of center of mass from the axis. And when vertical distance from the axis means this is mere distance, but name given to it is radius of gyration. Now, if we take this radius of gyration, this is the, let's say this is the mass, and this is the axis. So axis to, if it is center of mass, whatever distance is this k is the radius of gyration. Okay, this k is the radius of gyration, right? Now, if this is the rigid body having some constant angular velocity omega about the axis, then let's consider there are some masses around it. It consists of n number of mass but identical, but distance different, m, this is also m, but all are same. So this is also m having distance r2. Likewise, we can have mn and rn, n number but identical. So if we write the moment of inertia of m, then we'll write m r square. It can be m r1 square. Similarly, for second, it can be m r2 square. So for third, it can be m rn square, right? M rn square means we are now taking moment of inertia of the entire mass, which means m is common. So r1 square plus r2 square plus rn square. Now what we do, let's multiply and divide by n. If we multiply and divide RHS by n, then what we get? Moment of inertia I will be m into n, and this is r1 square, r2 square plus rn square, and divided by n. This m into n gives total mass. Therefore, we write I as total mass, and this remains same, r1 square, r2 square, rn square whole divided by n. Let's say 1. And we also know I as we can write total m into k square, because k is the radius of gyration, which is perpendicular distance from the axis. These two I are same, therefore we write mk square as m times r1 square, r2 square, rn square divided by n. So m and m gone, which means we get what? Therefore, k would be r1 square, r2 square plus rn square divided by n whole under root. So this becomes the formula for moment of radius of gyration, and this is the square of root mean velocity, distance of the individual particle. Square of root mean square of the individual particles is k, and k is mere distance, so it is measured in meter only, SI unit. Hope you have understood. Thank you so much.